Hello and welcome back. This video, if I'm not mistaken, should come out on the 24th of December, so Merry Christmas. And we are going to continue implementing functions. We have standalone function declarations handled. We can call functions, but now we are going to define local functions and closures. Okay, so the first thing he's talking about is that what is the parent of that environment we make when we make a function. So we actually did it in a rather reasonable way, that we just take the current environment that we're in that the interpreter is in, or rather, when the function is called, it gets an environment in. So let me see here. And the environment it gets is the current. So maybe that is not so great, because the current environment, it means that, let's see what it means. So let's make a function and it will just try to print a variable called a. So if we say a equals 2, and we call test, it will just print 2. And if we do like this, and then we call test, it should print local. So test is always working in the environment where, like, always working with the variables of the environment it's currently in. We can also do test, by the way, it should print 2. Which is not so great, because if we do like something like this, make test, and then we say a equals 2, and then we define a function that we call test, which does the same thing as before, it prints a. Then we say tester function is make test. Actually, that was wrong. Make test a equals 2. We declare the function and then we return the function. And then we say tester equals make test. And then we can call tester. We can call it and it prints 2. But if we say a equals a local thing and then we call tester, it will print local again. So it will not capture this variable. It will always use the variable that is in the current scope. So that's wrong. It should get an environment that it owns. But we actually had some trouble with that. So let's try to get that to work. Okay, so now first of all, I've changed the types up here, so it just takes a list of values again. And then there was something down here that needed to be updated, but if you're coding along, the compiler will tell you. And now we're getting this problem again, that it's becoming a function once instead of just a function, because it's moving this one out. So how do we fix that? Just trying to do this. What if we say clone? So bizarrely that worked. Let's run the tests. Tests are still good. And now if we make tester function, and it will make a local variable, it will like closure variable, we can call it. Then it will define a function test that prints a, and then it will return test. Then we can say tester is make tester, and we can call tester prints that. If we say variable a equals 2 and we call tester, it will still say closure variable. And that's great because now we can do things like, let's actually make a test just instead. So let's call it function closure. So we will use this example that he has because it's pretty good. Make a counter. We define a local variable. We call count, and count will increment this variable and it will print it. And then we will return count. And then we will have like counter 1 is make counter, counter 2 is make counter. And then we can call counter 1, call that a couple of times, and we'll also call counter 2 a couple of times. And then we should see 1, 2, 1, 2 when we run our tests. Not that, but here. And let's call it closure. Fun closure. And can add this back in. Yeah, let's keep it just so we're sure it doesn't print anything weird. Now we should have, I think, 5 lines. The first one should be 1, the second one should be 2, and then we need 2 more lines that says 1, 2 again. Let's run that, and it works. So just can try it ourselves. So it means that each of these have their own little environment that they can modify and work with. Which is super nice for functional programming. And incidentally, it's also quite similar to how an object works. So that was quite nice to get that fixed. So just a little note about implementation. We make an actual Rust closure whenever we see a function definition, and that captures some variables. And he makes a Java class that also has the statements and the environment in there. We could also make a struct that contains this data, but for now I think this is okay. So actually that's it for this chapter. The next chapter, resolving and binding, I think we are not going to look at right now. So let's try to implement this. Let me go into tests, cases, and we'll call anonymous. And that's not it. That's it. So we define a function thrice, which takes a function as argument, and it calls it 3 times with I from 1 to 3. So we have here this test, and we can go into the test cases. Do that. Function anonymous. Do that. Prints 3 things, so it should have 4 lines, and it should print 1, 2, 3. And let's try to run that. So it doesn't work, and it's saying error, expected expression. Who knows why it's saying it twice. But the problem is that when it's trying to to interpret this thing, it fails because it doesn't see this as an expression. So let's try to fix that. So I think we need to add something in here that is like we call it anonymous function, and it needs to have, let's see, we could do the same here. Oh, wait a second. So we have an expression that has the value of a, or that can be turned into a, or that when evaluated, it returns a callable. So we need something that when evaluated, it can be turned into this type. So let's see. We definitely need the arguments, and we also need the body. So let me see that. It's funny that this here, it has to be a function. Sorry, here it has to be a statement, but here I think it has to be an expression. So let me try to implement that and see how wrong it goes. So I think we need to have that the anonymous function is a vector of statements. I don't think there's any way around that, because it needs to support if and else and all that. So now it's kind of like a cyclical dependency thing. Like statements, they can contain expressions or other statements, and expressions can contain expressions and other statements as well. So it may bite us in the ass. So let's say a non-function, and it has arguments which we can use, and then it has body which we don't use when we do to string, and we will just say format arguments.length. All right. Next error is down here. Okay, so how do we evaluate an anonymous function? Anon function, arguments, body. Let's go back here. I want it to be a callable, but this is a little bit tricky. So the name is, we can just give it some random name. The arity is of course the length of arguments. Now the function, what does the function need to be? The problem is that we have a list of statements and we need to interpret them. But then we need an interpreter. So let me go in here and let's make a new method over here that we will call for anon function. And I think it's simply when you evaluate a new function, we can choose whether it captures variables or not. Let's say that it does capture probably the most reasonable thing. So the specials, it of course makes a new one. And there we go. And the environment is, well, let's make a new one. And just make it mutable. And the environment enclosing is clone of the parent. I guess. And then it's has to be wrapped like this. Because now we can say, give me an environment for anonymous function based on, actually, you know what? We don't need this because we're gonna clone it over here. Based on this environment that it's being evaluated in. And then we need the function. So let's say function implementation, and it's going to take, it's probably going to be very similar to what we have down here. So arguably this should be abstracted away. Just gonna copy paste it for now, try to get it to work. Sorry, so this should be an interpreter. And then you can call it once, which is not really what we want. So we need to move this one in here, similar to over there. It has to be mutable. And let's see if this works, or we have to do more things. So we make an interpreter for this function call. We go through all the arguments and we define them. We bind them to the parameter. Okay, so we need the parameter names, which should just be arguments, right? Let me see. How's the function declaration? Params is a list of tokens. So I think we should do the same here. The arguments are actually tokens. And then this is correct. We clone, we define the arg. Value, good. Then we loop over all the statements. We interpret them. We check if there has been a return defined. We return that, otherwise we return nil. And then the callable, or the function is this thing. And we are missing something. Expected. Great. See if it works. And it doesn't have interpreter, so we need to go up here and say use create interpreter. Probably we also need to write interpreter. And 278. And here I'm just gonna write anon function at line. And now let's let's also add the parentheses so we like have a line number to use. Then we need to fix this. And here we do that one. And I think that's that. Let me see. 279. Maybe we don't. No, we need to. I wonder if we could just take this interpreter and then like we can do this copy pasting, or maybe we can make this anonymous interpreter, make a function declaration. I think this is clearer. So what I'm just gonna do is make this public. And body is a list of statements. So do that. And we also need this. Right, and this one has to be wrapped in RC. So, and it has to be okay. And in interpreter, line 52. And now we have to say something like environment is environment.clone, and we have to move it, and then we have to use that clone over there. All right, I took a little break and now back. So I managed to solve it, and what needed to be done was just to clone everything that we want to use inside the closure. And that way we're not really taking it out of this, we're not taking ownership of it, we're just taking ownership of a clone, and that the compiler is okay with. So now if we run the tests, we get that the test still fails, but at least it compiles. Now the reason the test fails is because the parser is not updated, so we need to do that. And let's see, so now we can have an expression that's a function. So it's not at the declaration level, it's not a variable declaration, it's not a function declaration, it's a statement. So if we go into statement, then there is a bunch of things, and maybe it should live here an expression statement. And it can just be an expression itself, right? It doesn't have to be a full statement. So let's try this. So if we see a function token, then we want to pass a function expression. Otherwise, it's just an assignment. Well, what's an assignment? Value, and then it goes into okay, so it consumes something, then it sees if there's an equal, and okay, so it has to be after assignment. Or should we just call back up into expression? I'm not really sure where to put it in the hierarchy. So let's try this. And then we will say here function expression. Perhaps he says something about that. No. Okay. So let's see. So match token already consumes a token. So now we need like the name, which let me see how we do it for the function declaration. Declaration. Okay, so we can say that we consume an identifier. Well, no, wait. So we don't actually. We just, yeah. So we need a left parenthesis. And we will say expected after anonymous function. And then we need to do something similar. I mean, basically this, right? So we're just gonna copy it. So now we get all the parameters. We consume a right parenthesis. And we need to consume the left brace. And we'll say again, expected after anonymous function. Let's call it declaration. And then we need the body, which should be a block, I think. A block statement. And we'll do the same thing because if we go look at expr, our anon function takes a list of arguments. Sorry, a list of, but the body is a list of statements. So I want to do this, match this one. If it is a block, statement with statements, then body is assigned to statements. Anything else, we panic. There's a lot of repetition right now, but I just want to get it working before I worry about that. And I think that might be enough. And this one we will keep, I think. So do it like that, because then we can use it here when we make the anonymous function, the parentheses, arguments now called parameters, and the body. See if it compiles. It almost compiles because we need the loop here, and it's like so. And this gives us a vector of boxes, not a vector of statements. Maybe I just want to say that that's okay. Then it's gonna fail down here, which is also fine. It ran, let's run the tests. And it actually, that was sufficient. Let's try this. So now we should be able to say something like, this is a function that takes 2 arguments and it returns the sum. And because we're declaring a variable, we need this. And then we can say 1, 2, and it doesn't do anything because we need to print. Okay. That's pretty cool. What if we say b is equal to false or this? Right. Oh, it doesn't like that. That is very interesting. So let's see what the problem is. Go into the parser. So it's for sure that it's this OR thing, right? Because OR, it will go further down the precedence chain. So this way, it's like only at the very top level that we can do it. What if we put it actually, let's try something else just for fun. A is if true. Let's declare a variable and then we say if true, a is equal to a function that just prints hello. Right, so if true, a is equal to a function that prints hello, and because it's an assignment, we need a semicolon, and then variable true is because it's with small letters. And now can I call a? Yes. So it does work in there. Basically we can we use it also in, so let's make something we call a caller. It will just call a function that it gets, and then we'll say caller, call this one, and like that. So that also works. And why is that? That's because call goes back up into expression. So maybe it's okay because this use case, like this, is really weird. All right, why? I mean, we so let's assume that it's okay for now where we placed it. But what would happen? Like, could we get it to work? Could we get it to work? I'm imagining that we have to put it down here into primary. Then we can say, like, if we match a function token, we can even try now. Let me just see my function, expression function. It assumes we have already gone past the function token. So let's do this. Okay. So that actually worked. Now if we print A, and we can say B is false, or it's a function that returns true, and now we should be able to call B. And let's also, okay, we need to fix the rebel. It's a little bit bad. But the question is if we couldn't just put it right here to begin with. Like, let's comment this out and just call assignment here. And now we can say, like, caller that takes a function and just calls the function. No, it's not. Already forgot how it takes a function and we just call the function. Then let's call an anonymous function that prints hello. And that still works. And we can say a equals true, or a function prints hello. And that works. So arguably we put it down there because it seems like then we can use it everywhere. which I think is fine. I think it makes sense if we say that functions are kind of first class. Then they are handled in the same way as these guys. False, true, nil, number, string, literal. Then they are truly like the same, on the same footing. I guess we may live to regret this mistake, but let's as the final thing in this video, let's make a few more tests like this. Also, let me see here what he says. How do you handle the tricky case on a anonymous function expression occurring in an expression statement? What is so tricky about that? What happens if we say right, so print 2. There's a nice error message, I think. Reasonably nice. Okay, Phononon 2 and let's try to do something with like that modifies a value, and then we will say call the function that does this, and then print a. And now because my test framework is so bad, I need to do this. We expect 2 lines and 1 is equal to that. And it failed. 3 lines, there's an error. Let's run this, see what it says. Expected, of course. It expects a semicolon in there. And now it works. It's pretty interesting how easy it was actually. Okay, I think that's it for now. In the next video we will start on this chapter. So until next time.